Hi friends, myself V.I.Patil, and today we discuss about our fourth chapter, mathematical induction. So here mathematical induction means it is a tool which can be used to prove wide variety of statements. That is, here it is a tool we have to use to find wide variety of statements. That is, for example, we have to prove that 1 plus 2 plus 3 plus so on plus n equal to n into bracket n plus 1 by 2. So this is one statement. We have to prove this one by using the mathematical induction. And for example, 1 square plus 2 square plus 3 square plus so on plus n square equal to n into bracket n plus 1 to n plus 1 by 6 are some of the examples. We have to prove this one or these statements we prove by using the mathematical induction. And mathematical induction, the principle of mathematical induction, that includes three steps. So first step is verification. Means in the given example we consider as P of n. We consider this is P of n. So verification means we have to verify for n is equal to 1. We have to verify this given statements for n equal to 1. Then the next step is assumption. So we have to just take as assumption means we have to assume that the given statement is true for n is equal to some k. N is equal to some k for, and the next step we have to prove that the next step is induction step. If suppose the statement we have assumed that the statement is true for n is equal to k, then we have to prove that the statement is, that is, we have to conclude that the statement is true for n equal to k plus 1. So all the examples we have to solve using these in three steps. So here we go to an example. That is the same example we have to solve here. So right here that is the example we prove here. That is prove that or prove by mathematical induction. Prove by mathematical induction that 1 square plus 2 square plus 3 square plus so on plus n square equal to n into bracket n plus 1 to n plus 1 by 6. We prove this one by mathematical induction. So here we apply principle of mathematical induction. So the first step is the solution. So what we do? Let us consider, let P of n be the given statement. P of, consider given statement as P of n. That P of n is, what is the given statement? 1 square plus 2 square plus 3 square plus so on plus n square equal to n plus 1 to n plus 1 by 6. Now let step 1 equal to step 1. In step 1, what do we do? We have to put n equal to 1. So here let n equal to 1. Whenever you take n equal to 1, here LHS is equal to n equal to means only first term we have to take LHS is equal to 1 square is equal to 1. Now RHS right hand side is n is 1. 1 into bracket 1 plus 1, then 2 into 1 plus 1 by 6. So that is equal to, that is 1 into 2 into 2 into 1 is 2 plus 1 is 3 by 6. So here this get cancelled, 2 1s are 3, 2 3s are 6 and 3 3 get cancelled, that is equal to 1 comes. So here LHS is equal to RHS. Right? Left hand side equal to right hand side. hence, so therefore P of 1 is true. Means that is for n equal to 1 given statement is true. P of 1 is true means that is for n equal to 1 P of n is true. So this is the first step. Next step 2 is we take step 2. That is we have to prove that, let us assume that step 2, assume that P of n is true for n equal to k. P of n is true for n equal to k. That is, we take P of k as 1 square plus 2 square plus 3 square plus so on plus k square is equal to k into k plus 1 into 2k plus 1 by 6. We assume that this is equal to true. The given statement is true for n is equal to k. Now step 3. So step 3 is we prove that P of n is true for n equal to k plus 1. N equal to k plus 1 whenever P of k is true. Whenever P of k is true. So here k term is given. Now we have to take k plus 1th term. So therefore equation 1 becomes, that is 1 square plus 2 square plus 3 square plus so on plus k square plus the next term should be we take k plus 1 square is equal to. Now here first up to k term is equal to, this is equal to, that is given, that is k plus 1 2k plus 1 by 6 plus k plus 1 square, because this is equal to by equation 1. Now from both the terms k plus 1 is a common one, take it outside. K plus 1 into bracket, here left is k into bracket 2k plus 1 by 6 plus k plus 1. Now we have to cross multiply this one, so we take here therefore that is equal to k plus 1 into bracket, we solve this bracket, that is 2k square plus k plus cross multiply this one, that is 6k plus 6 by 6. So this is equal to k plus 1, LCM take outside, so this is 2k square plus 6k plus 1 is 7k plus 6. Now we solve this quadratic equation. The product should be 12, 2, 6, 12. So the factor should be, the addition should be 7 comes. So what are the factors? That is 4 3s are 12 and 4 plus 3 is equal to 7. So this is, we factorize k plus 1 by 6 into bracket 2k square plus 4k plus 3k plus 6 so here this is equal to k plus 1 by 6 into bracket, the first term taking 2k outside, remaining is k plus 2 and these two terms take 3 outside, that is left with k plus 2. So this is equal to k plus 1 by 6 into bracket 2k plus 3, or this is first we take this is k plus 2 common one, that is k plus 2 and left with 2k plus 3. So therefore that is equal to k plus 1 by 6 into bracket, this is k plus 2, we write it as k plus 1 plus 1. We write here k plus 1. Now this is k plus 2 as we write as k plus 1 plus 1 into bracket, this is 2k plus 2, we write it as 2k plus 2 plus 1 by 6. So therefore this is equal to k plus 1 plus 1, from this one take 2 outside, so 2 into bracket k plus 1 plus 1 by 6, and here the result is true for k equal n equal to k plus 1. Notice n is equal to here, n is k plus 1, then k plus 1 plus 1 and 2, n should be k plus 1 plus 1. So therefore P of k plus 1 is true, hence by principle of mathematical induction, the result P of n is true for all n belongs to n. Means for every natural number n, the result is holds good, and this is the solution. Okay. Similarly, we go to the one more example. We solve. The next example is prove by mathematical induction that 1 cube plus 2 cube plus 3 cube plus so on plus n cube is equal to n square n plus 1 square by 4. N square n plus 1 square by 4. So this is also the given statement. We have to prove this is universally we prove that by mathematical induction. So by mathematical induction, what we do? First we write the given statement and consider that P of n. Let us consider as P of n is equal to given statement as 1 cube plus 2 cube plus 3 cube plus so on plus n cube is equal to n square n plus 1 square by 4. So step 1 is when n is equal to 1, that is verify whether the result is true for n is equal to 1. When n is equal to 1, LHS, that is left hand side is equal to, for the first term 1 cube is equal to that is 1. When n equal to 1 is we take the only first term, that is 1 cube is equal to 1, and the RHS is equal to, that is n equal to 1 means 1 square into bracket 1 plus 1 square by 4. 1 square is 1. 1 plus 2 is 2 square is 4. That is 1 into 4 comes. 1 square is 1. 1 plus 1 is 2. 2 square is 4 by 4. 4 by 4 is 1. So therefore here LHS is equal to RHS. Hence P of n is true for n equal to 1. We conclude that the result is true for n equal to 1. Now we consider step 2 as we we consider the step 2 as assume that the result is true for n equal to k. We assume that this is the given result is true for n equal to k. That is 1 cube plus 2 cube plus 3 cube plus 1 plus n cube is equal to we have taken here k. So this is k square into bracket k plus 1 square by 4. We assume that the result is true for n equal to k plus 1. This is the step 2. Now the step 3 is we shall prove that the result is true for n equal to k plus 1. The result is true for k plus 1. Here kth term is given, so we add k plus 1. So therefore that is 1 cube plus 2 cube plus 3 cube plus 1 plus k cube plus k plus 1 cube is equal to, now here first up to 1 cube to k cube is, the term is k square into bracket k plus 1 square by 4 plus this is k plus 1 cube. So from both the terms k plus 1 square is a common one taken outside. K plus 1 square into bracket, we are left with k square by 4 plus k plus 1. So therefore here we take that is k plus 1 square. Now here cross multiply, that is k square plus 4k plus 4 by 4. So this is equal to, here this is k plus 1 square as it is, into bracket numerator should be, that is the perfect square of k plus 2. This is k plus 2 square, k plus 2 square by 4. Numerator is perfect square root, k square plus 2 2s are 4k, that is a plus b whole square. We know that a square plus 2ab plus b square. So k plus 2 by 4. So or we can write it as k plus 1 square, k plus 1 square by 4. Check this one. The result is, whenever the result is true for n is equal to k square k plus 1 square by 4, we prove that the result is true for n equal to k plus 1. That is, here n equal to, we have proved the result is true for k plus 1 square. Like k plus 1 square, n should be k plus 1 square by 4. Hence here the result is true for n equal to k plus 1. So whenever the result is true for n equal to 1, and if assumption is true, and whenever conclusion also true, so therefore by principle of mathematical induction, the result is true for every n. By principle of mathematical induction, the result, that is or by principle of mathematical induction, P of n is true for all n belongs to n. Hence the solution.